is that in those areas of low to moderate severity, we really have an opportunity to conserve giant sequoia. And what a lot of those areas are going to need is an additional fuel treatment to sort of like follow up and shore up what the fire already did. So we can take advantage of, in this case, the fire, it looks like it did a really nice prescribed burn that we consider restorative. We might go in and thin a few more trees, do another follow-up prescribed burn, and then hopefully get to a point where the forest is in really good condition. And then we're just thinking about doing management or maintenance treatments to sort of keep it in that good condition. And then when those fires come, again, it's just more likely that most of the trees are going to survive. Apologies, I needed to do a little more editing there. Okay, and so with that, I'm gonna wrap up and I'll stop sharing my screen so that I can introduce David. And then we'll have some time for questions on both this big picture stuff and the seedling thing, information that David's gonna share. We'll have a little bit of time to talk about that before we shift to the management folks. And so with that, I'd like to introduce David Soderberg. He works for USGS as a research scientist, and he is going to talk to us about what we're learning about seedling regeneration after wildfire and giant sequoia. So David, are you able to share your screen?
There we go. Sorry, I have to unmute.
I should have said that David Soderberg, he works at USGS associated with Sequoia Kings Canyon National Park. So he really works on a lot of issues in that part of the world.
Cool. Sorry, so my screen's being shared?
It's being shared, yeah.
Okay, there we go. All right, thanks. Yes, my name's David Soderberg. I'm an ecologist with the U.S. Geological Survey. And yeah, just Kristen, touched on a lot of great points with historical reference to what's going on with sequoia groves. And I'm just gonna dovetail onto what she briefly brought up with regeneration and some of the work that we've been doing. So back to what Kristen said, if we were talking about this in, say, 1980, we'd probably be talking about we need more flying sequoia groves. We need more of these patches of high severity to stimulate that regeneration, those big mats that she was talking about. But now fast forward and, we got a little more than we maybe would have wanted. Many of these recent wildfires in 2015, especially those in 2020 and 2021, were significantly larger. As opposed to these historic wildfires that were dominated by low and moderate severity, with these hotspots of high severity that we liked, they're big and dominated by much higher severity zones, especially ones that were contiguous in this high severity. And I'll talk a little more about that contiguous large area that can be problematic for regeneration. Kristen talked a little bit about the cones here, but just to reiterate maybe what she said is, giant sequoia regeneration generally requires a fire stimulus. Unlike other conifers, without fire clearing the forest floor and stimulating the seed rain from these trees, you generally don't get any regeneration. I mean, it's a non-zero number, but it's basically negligible. And the fire basically comes through, it burns the litter on the floor, exposes that bare mineral soil, and then the heat pulse goes into the canopy and stimulates that seed rain. You generally from the desiccation of the cones, so you get a green cone that's tight with its scales, and then the desiccation after it dies releases that seed. It hits that exposed soil once the duff has been burned, and you get this cute little region that comes afterward, and usually in large amounts of it when you get these high severity pockets. But a major point I want to emphasize today is that the severity of the fire has a large impact on the amount of regeneration that you get. So as Krista mentioned, this fire severity has a large impact on the amount of large seed-bearing trees that are killed. It's the same thing for regeneration. And so just an overview is that, at these lower fire severities, you have this picture here with this nice big green crown. The fire's low intensity. A lot of the heat doesn't get up into the canopy. Independent of what happens on the forest floor, you get seed release, but it's just minimal. A lot of that crown stays live, it stays intact, and your cone scales stay closed like this, and the minimal seed is released. But then once you get to the moderate to high severities, you get more a picture like this, where that heat pulse into the crown is a lot hotter, you get a lot of damage and even death to your canopy, your crowns, and your foliage browning. That's dead foliage. We also get dead cones, which when they're intact like this, is actually good for stimulating regeneration, because when they die, they dry out again, the scales open, and you get significant amounts of seed rain. But again, and Kristen touched on this, but these are some of those areas of concern that she brought up. They look like this, and again, she had that photo with that big, large sequoia in the middle, and no regeneration was found in the proximal area. And what we're thinking is happening, in terms of regeneration there, is that, rather than say this previous slide where you get dead cones but they're intact and they release seed, in this scenario, what we call maybe this more extreme severity, you're getting crown fire. So again, the fire, the heat pulse extends into the crown, catches everything on fire, and you can actually consume the cones and the seeds they carry through either direct consumption in the crown, or it stimulates the cones to fall to the ground during the active fire, and you get a lot of that seed source going away and not being able to germinate. And so, as Krista mentioned, this is a bad tandem of your trees are dead, and the replacement for them that you assume are going to be there potentially are consumed as well in the fire. And so this is that relationship that I just described, but a little backed up with some data. So this is just a slice of some data that we're currently working on. We've compiled the data set across, from Kristen's team and many other researchers who were working in the recent years. It's almost just shy of 1,000 plots across 27 groves and 3 different fires. This is just a piece of that. Those dots don't summate to almost 1,000, but this is just to show that relationship that I described, where at the low ends of burn severity on the x-axis at the bottom, I talk about that seed release, but it's related to how much regeneration you get on the ground. You get, not that much regeneration at the lower end of burn severity, and then it climbs as you get hotter pulses. And it looks something like this. It's a hump shape. And these hot spots that Kristen talked about that, were deemed generally good for regeneration, happen probably somewhere towards the hump, or at the right towards the hump of this curve, where you're stimulating a lot of regeneration. But as you get into these more extreme parts of the spectrum here, regeneration starts to tank, and that's generally related to when things get too hot, you get crown fires, and your seeds actually consumed as well. But it's not, as we're showing here, and mechanistically it makes sense that the burn severity relates to the amount of regeneration you get on the ground. Something very significant that we're finding too is that it's not just the burn severity, where too hot, has these detrimental effects, but the post-fire climate, which we're also seeing big swings and high variation and extreme weather events in, may have a lot to say in the amount of regeneration you get on the ground. Because you can also get something like this. So both of these graphs are the seedling densities, the amount of seedlings we're finding on the ground. Both are across the same burn severity spectrum, and both are taken 3 years post-fire. They're just from 2 different fires. And so the first figure on the left is from the KNP 2021 fire, and just 1 year before that was the 2020 Castle fire. And the seedling densities, again, across the whole burn severity spectrum, we're not trying to compare apples to oranges here. This is as close as we can get to apples, is you have over 10x, so an order of magnitude difference in the total amount of seedlings you're getting. Now, there's a few explanations I could throw out here, but the main one seems to be climate driven. So after the Castle fire, we had the hottest and driest summer in our over 120-year record, which we have climate data. And for those of you that have seen Sequoia seedlings, or even a Sequoia seed, which looks like just a little oat flake, they're really fragile. They're really small and likely very susceptible to drying, to hot temperatures. And this is likely maybe what happened here, is you had such an extreme weather event in the year following the initial burst of regeneration, which is by far and away most of the regeneration. Our data shows over 80% of the regeneration falls within the first year. Almost 20% second year, and it was negligible in the third year. So within this small 2-year window, if you have an extreme weather event, that's not good. If you have a lot of your trees die, and then you're hoping the regeneration is going to come at the back end of that, and then you get weather events, this could be a scenario of concern. And a point I'm trying to highlight as well, I want you to take away with, is that all high severity effects are not equal. And so kind of back to these hotspots that I keep referring to, where you get lots of regeneration. These are always referred as high severity. High severity is really good for giant sequoia, and that is true in certain contexts. But all high severity, again, is not created equal. So on this pink rectangle here is on the lower end of high severity. And it might approximate something in this picture I've showed previously, which you kill the trees. The majority of your seed-bearing trees are killed, but the seed is intact, seed rain is strong, and the regeneration fields are strong. You're still in this high density part of your regeneration hump. But as you can see here, this is also called high severity. And you have a different context. You have canopy fire, where again your trees are dead, but we're getting into less certainty that the regeneration to follow is going to replenish what was lost. And so again, this has your double whammy, which has folks like Kristen concern, which is you get at the very, very high end or extreme ends of high severity, you get heavy loss of mature sequoias, and you're getting these relatively lower rates of regeneration levels. And it's not just that, it's back to the first figure I showed, which showed that large patch of high severity. It's not just these small pockets that are well within the seed range of surviving trees, but you have these large patches that are potentially very distant, have a lot of areas very distant from seed sources down the road. And so it's right for managers to be concerned about the future of these areas. Now to step back, just what a good burn might look like. So this is just an image of some of that satellite data that Kristen mentioned, that we can use satellite imagery to see the burn effects on the ground. And these are 2 sequoia groves that burn the rough and KMP fire, and we would consider these probably really good burns. You have a modest amount of tree mortality, or it's dominated by low and moderate severity with these pockets of red high severity. And you probably have a modest amount of tree mortality, but not too much to raise your hair, and you're likely to get a good amount of regeneration stimulated after these fires. But we're also getting this happening to other groves. So again, this same fire, but just the rough fire, but the Converse Mountain Grove, and then one of our bigger sequoia groves, the Freeman Creek Grove. So for example, in the Converse Mountain fire here, you're not dominated by low, moderate pockets of high severity. 95% of that grove burned at high severity, with a quarter of the grove burning at what would be very high severity, and then 22%, 3/4, and then a quarter of the grove burning in something resembling that photo I showed earlier, where you have crown fire and everything's dead, and the regeneration is likely very low. Now, the Converse Mountain Fires, Mountain Grove is a relatively smaller grove, and I showed the Freeman Creek Grove, again, one of our larger groves, where 904 acres burned at high severity. Now, Krista mentioned about 25,000 acres in total. So that's, 3%, if I do my math right, of all the giant sequoia grove area burned at high severity in just this grove alone. So from a manager's perspective, this isn't just like a day trip to go see what happened. You might really have to take some trips to go out to see what's happening on the ground if conditions are as bad as you might worry about. And why we're worried about some of these really large areas of burn severity, again, is because of the seed rain. So if you have a significant majority of your large seed-bearing trees killed, if you're in a pocket, those trees are killed, the seed rain is well within reach to reach those pockets. But if you're in a really large area, a significant portion of that could be away from where you might get seed rain from the trees that are still standing. And so these larger areas, we found in our research, we even decline. It's not just the burn severity alone that's showing low regeneration levels. You actually decline your regeneration levels the deeper you get into these large patches. And when I talk about acres or hectares or these different units of area, I thought I'd just translate the football fields. And so from a manager's perspective of, I'm worried about Freeman Creek. How's Freeman Creek doing? It's translating the area here is, you have 685 football fields worth of high severity. 600 of will be doing very high, and 350 football fields worth of extreme severity that, for the reasons I'm mentioning, that Chris mentioned, should be of concern for managers to think about, if intervention would be needed. but that's up to those agencies. So to put this into, again, historical context, what's happened with these since 2015 and 2021 fires, Kristen had this timeline of affected sequoia grove over time, and she did mention all the good fire effects that have happened. I'm just showing here the extent of not just high severity, but very high and extreme severity, those upper ends of the spectrum. As much as we did get, a lot of good, low, moderate, and low high severity area burns with good beneficial fire effects, these potentially very detrimental fire effects of close to 100% mortality and weak regeneration is unprecedented in what we can see with our satellite imagery or in the history that we know about for Sequoia. It wasn't until these years, and these years alone more or less, that groves have burned like this, and to the extent, and to the contiguous nature of those large patches. That's why we are having these active research programs to see what's going on the ground.
Yeah, I gotta make it quick.
Yep. All right, so takeaways. The relationship between burn severity and seedling density. You go up, you go down, and we're concerned about that down. Post-fire climate, it's this giant driver of how much regeneration you're getting on the ground, post-fire climate immediately after fire. And this is leading us to have concerns about the next years of what these severely impacted sequoia groves are looking like. Yeah, that's it. Thanks.
Thanks, David. That was awesome. We have a little bit of time for questions. Katie and Bree, have you guys gotten any that you want to ask either of us?
Sure. I think we have a couple. I don't think I introduced myself earlier. My name is Bree Baker. I work with Kristen at UC Berkeley, and I'll be kind of moderating our questions a little bit today. Starting out, maybe we can go back, and I have a question for you, Kristen. It's a little bit more of a pre-fire question around fuels management. So some of the pictures that you showed included some examples where you can see that there were saplings cut down or removed during fuels management. And the question is whether that, if you can speak to whether the removal of those saplings and young trees during fuels reduction threatens stand and forest continuity and longevity.
I'm sorry, say that again.
Forest continuity and longevity. Yeah, I think that the photos that we're referencing here, if I'm recalling correctly, are some of the pictures where you can see young firs and pines that have been cut down.
Mm-hmm. Yeah.
I think thinking about sequoia groves as a sort of sum of a whole that is not just the sequoias but also the trees.
Right, sure. That's a great question. I mean, the one thing that I think we're not going to have a lot of problem with in those pre-fire conditions, again, before we've lost all the mature seed trees, is getting trees back, right? So historically, we think a lot of these forests had 50 to 100 trees per acre. We regularly find 500, 600 trees per acre or more. So cutting those out, the small trees, really it reduces that fuel load and reduces what we call the homogeneity, which means that fire can't just sort of rip uniformly through. But we don't cut out every single seedling, over large areas. We don't cut out every single seedling. So there is going to be some differentiation in the size classes of the trees growing there, and there will be continued seeding in. There's sort of never fear that we will get more trees as long as you have those seed trees present.
Great. Thank you, Kristen. Then maybe we have a question for David as well. So David, you talked a lot about how climate can, or seems like it might be limiting regeneration even when we do get these seed rate events. How do you think that managers should take on this question of when do we replant versus when will it be too hot, too dry to replant? So kind of translating from the natural regeneration into some of the direct actions that we consider taking.
Yeah, it's a good question. It's kind of an active question of how much regeneration is enough. So I was talking about these relative amounts of regeneration, say, across the burn severity spectrum, but it really, I guess it boils down to it's up to the management agency. So I mean, I guess my position, I can't tell them what to do. I'm just here to kind of present what we're seeing. And it just depends on the target goals of the management agency. You know, as the Forest Service, they have stocking densities, and so they might want to hit certain targets. So they might find the regeneration is really poor after, you know, maybe there's an extreme dry event after, you know, after a fire. They might want to plant to meet their stocking densities, but it really just depends on the management agency to determine what is enough. One issue with, you know, natural regeneration has its small window to be successful immediately post-fire, because, you know, seedlings are really small. They can't land on a bunch of litter and get into the soil and germinate and become like an extra. It's many years down the fire. They need to do that immediately, whereas a planted seedling could potentially do that later down the road. And so, yeah, I guess I can't really say when to do that. Is up to them. Depends on what they're trying to do. Yeah.
David, I'll follow on to that. I just wonder if part of the question was maybe also thinking even further ahead, what happens when these areas, like some of the areas, are persistently too hot and dry, right? And I think that is a real conundrum of when it's kind of like, when do you decide to let go of an area and to sort of stop trying? And I think some ways that's as much of a value judgment and an emotional decision. I think right now I don't know, and David, I'd love to hear your perspective. I don't know that we have like, that scientists or managers feel like we have a clear idea of like, yep, once we cross this annual temperature threshold, we won't plant there anymore. You know, it's a very nuanced, these are very nuanced decisions, and it's very tricky because you could, like you said, it's the climate, even as it's overall warming and drying, it fluctuates, right? And so you could end up having, you could end up having basically a couple of good years, even if overall it's sort of trending in the wrong direction. And so, but that is something that I think we're going to have to wrestle with as some sites do eventually become inhospitable.
Yeah, ultimately you would be able to create a situation where you're not getting the majority of your growth dying and having to worry about this immediately, you know, replacing that for the succession after them. Optimally, you would, even with highly variable post-fire conditions, the managers could, you know, implement plans where you're going to moderate the fire behavior, and so you don't have to be put in that position. And then it's less of a concern.
Kind of following off of that, and for both of you, do we have a sense on how many good years that we need for some of the young saplings, seedlings? I mean, how many good years they need to be able to produce a viable set of regeneration?
We don't have currently an accurate understanding of mortality rates in the immediately post-fire window. We do have some data on it, but it's contextual based on how dense it is with competition. Mortality rates are affected by, again, the post-fire climate. And I don't get too deep into speculating, but you know, the farther away you get from a fire, the more stable your mortality rate is going to be lower and lower over time. So I guess all I can say is your mortality rate is much higher in the first 2 years following fire, and then things will stabilize a little bit. But the extent to which that is, the percentages, the rates are always going to vary in the context, and we don't have concrete data on that.
Great. Well, I think that might bring us to time to head over to our panel.
Great. Thanks, Bree.
Back over, Chris.
So I'm not going to introduce everyone individually. I'm going to let them all introduce themselves. We're going to basically plow through a bunch of presentations, and they're going to share a little bit about what the challenges, how the fires have been impacting them, the challenges they've been facing, and the kind of work that they're doing. So I'll get us started by sharing my screen again.
I'm just going to say really quick too, if anybody has questions for any of our speakers during this rapid fire presentation, on the bottom of your screen you'll see the Q&A feature. That's where you can ask questions, and just like we did here, we'll answer all of those at the end, but feel free to drop those in there. And thanks again, Kristen and David. That was great.
Awesome. Okay, Marianne, go ahead and kick it off when you're ready.
All right. Hello, everyone. I'm Marianne Emmendorfer. I'm a forest silviculturist on Sequoia National Forest, Giant Sequoia National Monument, and I'm the Giant Sequoia specialist there as well. So I get to focus on tree health, growing trees, and in particular sequoias. Next slide, please. So, as I mentioned, I'm on the National Forest, and where all of our sequoia groves are located is in Giant Sequoia National Monument. So that was established in 2000 by the president at that time, William J. Clinton, and it's about 300,000 acres, and we manage the variety of grove complexes as 33 entities that we manage as one unit each. We do have some named trees and some known isolated sequoias that are located fairly far away from the rest of the sequoias, and we make sure to manage them as well. Next slide. So as shown on the map, the monument is broken into a northern and a southern section, and the majority of this landscape has been affected by the recent drought and the fires. So on the northern section, where it shows Chicago Stump on your screen, that was the Rough Fire. To the south of that, where Redwood Mountain shows, was the KMP complex. On the right side of the screen, on the southern portion of the monument, we have the Castle complex, or the KMP complex and the Castle fire, the SQF complex, I apologize. On the northern portion, and then the Windy Fire soon after it in the southern portion. And almost every sequoia grove that we manage has been burned in a fire since 2012. Next slide. So the timing of the fires, as Kristen and David were explaining, and the fires themselves matter. So the Rough and KMP complex, for the most part, the effects were moderate to low, in part because of the timing of the fires at the beginning of a long drought cycle for the Rough, and we had a lot of active management in the vicinity of the fires when they got onto the National Forest. In fact, with KMP, as the fire was getting ready to run up the drainage onto the forest, I had contractors literally moving their equipment out of the area after they had just completed work on reestablishing fuel breaks. In the Castle and Windy, we had a lot higher fire damage. A lot of this area hadn't received a lot of active management in recent times, and this was later in the drought cycle, which started in 2012 and extended into about 2019. And so we had massive amounts of dead trees standing on the landscape, along with the dry conditions that helped fuel the intense behavior of these fires. Next slide. So since those fires, and as an ongoing thing, we're always looking to reduce high fuel loads and break them up across the landscape, protect our live trees and our key wildlife habitat, and then improve safety both for employees and for the public that uses this land. And our treatments vary across the landscape. They include mechanical treatments and manual treatments, prescribed burning, and then of course planting. And so within the groves in the last several years, I've got the statistics on the screen. since 2023 through 2025, we've treated the majority of our sequoia groves and reduced fuels in them, and we've replanted some of those high severity patches that David showed, and we've treated approximately the same or more acreage in the areas surrounding the groves as well. Next slide. So our management concerns, it's really about getting the restoration work done at a rapid pace. And the things that affect our ability to do that is we have a large complex landscape, and we have certain things that we have to protect that affect the treatments that we can have on that landscape. We also have a lot of fuel that's accumulating through the regrowth and the dead trees coming down. And then we also have a lot of partners that we're working with, which is a wonderful thing, but coordinating them and their efforts to make sure that we don't get the cart before the horse. So we want to get the fuels reduction happening before we would try to plant those areas again where we have a little regeneration. So it takes a lot of coordination and management to make things happen. Next slide. So we have a lot of treatments that are planned already in our groves in addition to what's going on. So, we're continuing the work that's going on, and these are in a variety of groves that include, manual and mechanical treatments, pile burning, underburning, in groves across the monument, and sometimes in partnership with other managers of groves like the Park Service or Tule River Tribe and Mountain Home. Next slide. More of our planned treatments going into the future. We're looking at additional work in alder starvation, Deer Creek, and Pierrone groves, starting as soon as this year and moving into the future. Next slide. So some of the unique challenges we have, as Kristen mentioned, the variety of capacity issues. We've had a lot of staff turnover. The funding is always going up and down. We have training and certification requirements that people have to even do some of the work that's required. And then we even had issues with our tree nursery and their capacity to provide enough seedlings for us that are healthy and disease-free to plant. Because we can't just go to Lowe's and buy a bunch of trees. We have to go through and make sure that we have healthy seedlings to put in that don't introduce pests. And we have the monument plan has a diameter limit of 20 inches, which can make it difficult to remove all the fuels to truly improve forest health and restore proper function to the ecosystem. We have stochastic events. In 2023, many people in California remember the atmospheric rivers that hit all of us. That caused a lot of delays and changed the landscape in some cases. And then, timing is a key piece of anything we do. The seasonality of field work, processing timelines when we're working with partners to get funding in place and grants and things like that. And then, of course, the burn windows are very limited, especially when our wildfire season has extended. That all affects it. And then one thing that was really unique that we've run into with these recent fires is giant sequoias as hazard trees, which are objects to protect in the monument. So next slide, please. We went ahead and we developed specific guidelines for the large sequoias that, like in the Evans Grove complex, can be right next to a road that people drive. So we developed an addendum to our hazard tree guidelines to help guide managers on when and where a large sequoia might need to be cut down before it falls down and hits somebody. So we're continuing to move forward and trying to abate the hazards to our sequoias and the people using these public lands. Next slide, please. And I'll turn it over to Jim. Thank you very much.
Jim Crowell. I am the forest manager at CAL FIRE's Mountain Home Demonstration State Forest outside of Springville, California. We have been threatened by and finally burned onto on a couple fires leading into the castle, and then the castle in 2020. The SQF complex was the one that really tested a lot of our treatments that have been done on the forest over the last 80 years that has been under state ownership. I'm a registered professional forester. Prior to coming to work for CAL FIRE, I worked industrial timberlands, consulted for almost 12 years, ran my own business, and then came over to Mountain Home after doing a project over on the Alder Creek Grove when it was owned by a private entity prior to say the Redwood League's acquisition, and knew that I had to do more over here to kind of round out my career and give back to the public. So next slide, please. So Mountain Home makes up just a little over 5,000 acres. We are almost entirely surrounded by the Sequoia National Forest to the northwest, the west, and the south of the property boundary line that you can see there. And then we butt up immediately adjacent to the Golden Trout Wilderness on that broken, jagged line to the northeast. We have 5 general campgrounds, so that's our primary charge at Mountain Home, is to provide recreational opportunities to the public with timber production and forest management and giant sequoia preservation as a very close runner-up. Next slide. So we first got wind of the SQF complex when it was 2 small fires burning in the Golden Trout Wilderness, and the fire burned for almost a month before it entered onto the forest, which was it reared its ugly head. On Labor Day weekend, and trying to evacuate 97 campsites and the 70 campsites at Tulare County's Balch Park on Labor Day weekend proved to be quite difficult, but we got it done. And then the wind shifted and the skies cleared, and we had about a week to go out and do some work around some of our infrastructure. And then the following weekend, on the 13th of September, we finally brought resources in to start reconstructing fire line that was put in during the deep fire in 2004, and discovered that we had fire throughout the forest in various stages of intensity. So we lost about 1,800 acres of the almost 5,070 acres that burned at high severity, literally stand replacing fire. The remaining acreage experienced really low to moderate intensity. I mean, it was, initially my first observations were, wow, man, I mean, if this is what a wildfire looks like at Mountain Home, I'll take it, everywhere. Until we started getting around the fringes. But internally in the main part of the grove, it looked really good. We had great fire behavior, mostly due to past management activities. We did intensive salvage harvesting during the 6 to 8 years of drought leading into the castle, and it really paid dividends. I mean, we surround Balch Park, and Balch Park experienced very little mortality. Most of the trees that were damaged or died on the county level were trees that were receptive fuel beds in and of themselves that burned from the top down and from the inside out, which is a lot of the mortality that we experiences as well. And then, we did a 200-acre prescribed burn in 2019, 11 and a half months before the SQF complex entered onto the state forest. And the very eerie thing was, in the area where we had done the prescribed burn, the large old growth chunks and big stumps that were spared in the prescribed burn was the only fuel present, and that was a receptive fuel bed, if that's any indication of how dry the conditions were. Next slide, please. So the main focus that I've had as the manager here, immediately during, in the 85 days that I was on that fire, and probably equal amount of hours that I slept during that period of time, it was, what are we going to do to get the forest back to a condition that it was prior to? And now, granted, we're never going to see this in our lifetimes, but I started preparing harvest documents, so on and so forth, because I wanted to be first out of the gate when spring came in 2021. I had a great plan. I ordered 212,000 seedlings, all of which were ready to plant in 2022. However, I anticipated hauling 25 to 30 log truck loads a day of salvage timber off the forest over the course of the next couple of years. And the mill said that our local sawmill said they would take every log that we could give them as long as we didn't send them more than 8 loads a day. So created quite a challenge. What am I going to do with all these seedlings? And, we move forward. That's another story. But anyway, since the fire, we've salvaged almost everything that burned that we could get conventional logging equipment on. We've done a considerable amount of site preparation, whether it was burning, logging slash. We've done over 1,000 acres of herbicide treatment. We've been piling and burning. We've done some broadcast burning, and we've done a considerable amount of tree planting. To date, we've got almost 240,000 seedlings planted, and we're scheduled to receive another almost 50,000 or almost 48,000 trees in 2027. The brush response, this was a failure on my part. We were not seeing much of it for the first couple years. It looked pretty good. By the time I had the contractor come out in the spring of 24, we were looking at deer brush that was about 18 to 24 inches tall, and when they showed up to spray the following spring, this stuff blew up to average height of about 5.5 to 6 feet. Currently, we're focusing on reestablishing the shaded fuel break, which really moderated fire behavior coming out of the Wishon Fork of the Tule River Canyon, and we've been burning that logging slash and blowdown. And just to give you an indication, we're all hearing that we're out of the drought, but last week we were burning under really favorable conditions, considering that we were surrounded by black acres. But the little bit of duff that was on the ground with 11% relative humidity values, one pile to the other looks fantastic. Next slide, please. So, unique challenges. Mountain Home is a destination forest for the general public, from local here in California to international clients that come here to look at giant sequoia. Marianne touched on it earlier. What constitute a hazard in these fire-weakened trees, and the tree parked there in front of my truck. That thing was about 13 feet in diameter. It left a 4.5 foot trough in the middle of one of our roads. It took us 2 years to coordinate efforts to remove something like that. I do have one tree in a very popular campground that needs to be resolved, just because it's an attractive nuisance. But anyway, I touched earlier about the brush response, kind of put us behind the ball. Unfortunately, with all the CAL FIRE grant money that's out there, the state can't pay the state. So I congratulate everybody that gets some of those dollars. We get none. So we have to be very, very careful and very diligent in our planning efforts to try to get a lot done with very little. Cooperation with the Sequoia National Forest is going to be critical to protect our boundaries. I've got some ideas. I've been in discussion with the Sequoia, and I'm hoping that Marianne and I can sit down and talk about some of my ideas. And then the delayed mortality has been, it's been rather depressing. You know, I think all of the grove managers probably did not anticipate that we were going to see these trees dying 4 to 5 years after the fire moved through. I have my theories, which are all based on anecdotal evidence, but yeah, it's a challenge. I can say so far this winter we're not seeing any additional dieback in Sequoia since we've been watching them over the course of the last almost 6 years. What I can say is that it looks to me like it's cambial damage. I think a lot of what we're experiencing is we did not have a very good winter going into the summer of 2020. We didn't have much of a snowpack. And my gut just tells me that a lot of this delayed mortality was because that thick bark didn't absorb any moisture and the duff didn't absorb much moisture. So when even low intensity fire crept around these big trees, there wasn't any energy being released in the form of steam. It would just chew through that bark and get right into the cambium layer. So there was a comment made earlier about seedling survival. I totally agree with David. A lot of it is timing. And I hope maybe he can comment when I'm done or at the end of the panel discussion on the amount of seed rain and the snowpack that was received immediately after seed rain. We didn't get much snow that winter in 2020, 2021. We did have in the spring, we had a considerable amount of seedling development throughout the forest where the groves were. But most of it we only observed in the cotyledon stage. And once everything dried, you know, the little bit of moisture dried up and it got warm, all that stuff died, except in areas where there might have been a branch on the ground that held a little bit more snow, shaded the snow and kept it for a little while longer. We did have some nice pulses of regeneration in those areas. So we really focused our planning, especially on the south facing and west facing slopes, to looking for those microsites behind logs or stumps or whatever, and trying to focus our planning efforts underneath that. So thank you very much.
Thanks, Jim. I'm up next. Hi, everybody. I'm Ben Blum. I'm the Director of Stewardship and Restoration for Save the Redwoods League. And really excited to be here with you today. Next slide, please. So what I do, so I'm the Director of Stewardship and Restoration for Save the Redwoods League, which means I oversee our restoration program across the state. We're a nonprofit organization that's been around for a little over 100 years now. And our mission is to protect, restore, and connect people to redwood forests, both coast redwood forests and giant sequoias. So we work in both those species ranges within California. Within the giant sequoia range, we kind of wear several different hats. because we're kind of an unusual nonprofit where our focus is really a whole range of a species, we're kind of uniquely positioned to be kind of a convener and supporter for giant sequoia work that happens across the whole range of the species. So we've been one of the kind of the key folks that have been really bringing together a group called the Giant Sequoia Lands Coalition, that is basically consisting of all of the folks that manage giant sequoias across the whole range, whether that's agency folks like Marianne and Jim, tribal partners that we work with, and a whole host of other nonprofits that we work with across the whole range. So we're kind of a convener and backbone for that group. We own the largest kind of privately owned giant sequoia grove in the range, and that's a place called Alder Creek Grove, which Jim actually mentioned in his talk briefly. That was the last, largely privately held grove within the range, and we purchased that grove in 2019 for long-term protection. So we purchased it about 6 months before the Castle Fire. I wish we had more time to do some work out there before the fire hit. And so we are a steward of giant sequoia groves on our own lands. We also partner with others. So we've supported work at Calaveras Big Trees State Park in the past, and now we are kind of in year 4 of a 5-year partnership with the Sequoia National Forest to work with them on the Giant Sequoia National Monument to improve forest health across several groves within the National Monument. We also have a science team and support science and applied research across the giant sequoias. And everything that we do in partnership. Because we manage a private giant sequoia grove, it gives us a little bit of flexibility that public agencies don't necessarily have. So we've been able to use our Alder Creek property both as a place where we can do applied research, but also as a place where we can bring people together. So we host cultural burns with our tribal partners there, and we're able to do kind of some unique things that would be more difficult on public lands. Next slide, please. So the map on the left shows just a different perspective on the full range of the giant sequoias. All the way in the north, up on the Tahoe National Forest, is the furthest north grove, which is kind of, each grove is outlined in basically in brown there. And so, as I said, we've worked within Calaveras Big Trees State Park. We also own a property adjacent to that state park. But the focus of our work in the last really 4 years has been in the southern end of the range. And that is kind of highlighted in that second map there. So Alder Creek is the grove that I mentioned previously. That's that furthest north grove that's outlined in red. And then we've taken on stewardship and support for the Forest Service and other groves within the National Monument within this larger area. And so, back in 2022, we were talking to our partners, particularly the Forest Service, about what we could do post-fire. So this whole landscape had burned either within the Castle Fire in 2020 or the Windy Fire in 2021, and there was just an incredible amount of post-fire work that had to happen within the National Monument and on our private property there at Alder Creek. And so we were looking around for places where we could really use our expertise and kind of leverage that to get more work done on the ground than could otherwise happen without our support. And we focused around 4 groves. So one was that Alder Creek Grove, and there's portions of that grove that go onto the Forest Service as well. We also identified Long Meadow, Pack Saddle, and Freeman Creek groves, and those groves were identified because they all had some kind of patches of low or moderate severity fire where we really felt like we could do good work in protecting the remaining healthy trees and restoring drought and fire resilience within those portions of those groves. So really kind of building off and trying to take advantage of some of the good fire that happened through these really incredibly large and destructive fires. There were also places where we felt like we could do some work to prepare for reforestation in places where we had what we would call regeneration failure, like what David Soderberg talked about in his talk earlier. And our larger goal is to really prepare this entire landscape for fire to be kind of the ultimate goal and management tool for the stewardship of these groves into the future. And we always do that in the kind of the context of protecting and improving wildlife habitat. So while a lot of these groves have been heavily impacted by fire, some of these areas in between the groves have been even more impacted. And so in some cases, these giant sequoia groves are some of the best remaining habitat for our species that we're most concerned about. So we're trying to do this work in the context of also protecting those species that are out there. Next slide, please. So, since 2022, we've worked in those 4 groves. As I mentioned before, we've got a 5th grove that we're going to be treating this year, Starvation Creek. And we do a mix of different things. So, over those few years, we've done about 1,800 acres of manual fuels reduction, and that's a picture on the left. Kind of gives you a snapshot of what that looks like. In most cases, that's working in low to moderate severity burned areas. So you can see a little bit of fire scarring on the base of that monarch sequoia tree on the left. So this is a grove that burned at low severity in the 2020 Castle Fire. And as you can see, there's just an incredible density of trees remaining even after that fire. And so we bring crews in, we're trying to clear some of those smaller trees away from our monarch trees, reduce the density of trees within these groves to something that more approximates pre-European settlement conditions, and set these groves on a trajectory to allow good fire to play a role in the future. We've also done some planting. So that picture on the right shows some seedlings that we planted. So we planted about 58,000 seedlings across our project sites since 2022. And that's really in areas where we've previously surveyed and seen that there isn't that natural regeneration coming in post-fire. We've also done, if you go to the next slide, please. We've also done some thinning and construction of shaded fuel breaks. So some heavier thinning around the cores of those groves to allow us to reintroduce good fire in the future. And so, in a lot of these places we're just removing standing dead trees and just reducing the density of standing fuel within these places so that fire can play its natural role within this landscape. We also support burning, and we've done some burns ourselves. We've hosted, as I said, 4 cultural burns with our tribal partners, completely led by our tribal partners on our property there at Alder Creek. And that's really about, bringing culture into the conversation about managing these groves. And that's part of our solution for better managing these groves in the future. We've also started on prescribed fire and doing that on our grove there at Alder Creek. And that's represented in that picture on the right. Next slide, please. So this is a little bit of a case study. This is our Alder Creek Grove. The different colors on the map represent the different severities of fire in the 2020 Castle Fire. So you can see about a third of the grove and our property there burned at high severity, which is represented in the red there. And then, kind of on the edges of that red, you see the yellow, that's moderate severity, and the green is low severity fire. And so we had kind of a mix, and there's a ridge line that runs right along that red to green boundary. So, there was a little bit of luck involved in how this fire burned and leaving kind of a green core of this grove in relatively good shape. So the Castle Fire happened in 2020. Starting the following year, we went into that red high severity area to reduce the amount of standing dead trees or snags within that area. There was just an incredible density of dead trees, particularly white fir in that part of the property. So we went in and removed a lot of those dead standing trees. Following year, we replanted in there. And have had really good seedling success since that planting, primarily in 2023. And then we've done a whole bunch of work within this green part of the grove too, and that kind of hand piling and pile burning work that I was showing in that previous picture. And then starting last year, really in 2024, we've started bringing fire back into the property through use of cultural burns led by our tribal partners, but also broadcast burning that we've done, led by Save the Redwoods League. So that gives you a little kind of set of context. Some challenges that we've dealt with. There's a whole bunch of challenges that we could talk about. There's just a broad landscape and just a huge scale of work that has to be done. So kind of trying to find ways to prioritize our work and where we get that work done is always a challenge. Limited windows exposed for doing broadcast burns is always a challenge. So that's another one that we deal with. One thing that I just think is really impressive is just how our coalition of folks that manage giant sequoias has really come together over the last few years to accelerate the work that needs to be done within these groves. And that's been represented by some of the presentations you've already seen. And I think that's it for me. Next slide.
Great, thanks, Ben. I'm going to start my timer here. I will talk about this forever. My name is Danielle Thomas. I am the forester for the Bakersfield BLM field office, and we manage Case Mountain giant sequoia groves. If this is the first you're hearing of BLM managing giant sequoia groves, you are not alone. It's not widely known, but that's okay in some cases. You can go to the next slide. So, Case Mountain is in the middle of that southern cluster of our sequoias. We are right on the edge of Sequoia National Park, just outside of Three Rivers, California. On the right, that shows you kind of the spread of our sequoia groves. We manage it as 6 distinct giant sequoia groves, but there is some debate about what a grove really is, or a unit, but that's for another seminar. So you can see on the map, the yellow is all BLM and the white is private. So we have about a 50-50 split, maybe a little more on private, but we have really great private landowners up there. And so a lot of our active forest management, we're able to treat across all 6 groves, no matter our boundaries. So it's amazing. You can go to the next slide. So our area historically saw a lot of logging and grazing, and the most recent wildfire was in the 80s. And since then, like Kristen said, there's been a lot of work put into trying to do some fuels reduction, but we just didn't do enough. So that brought us to 2024, and the most forest managers talk about, I feel like, managing forests as if it's like a ticking time bomb in some ways. Like, we are, before the fire came, I was trying to get a bunch of stuff done so that if a fire came, we'd be ready. And now, even after fire came, I'm trying to get a bunch of stuff done so that it doesn't reburn, and we've got, we don't see a lot of negative effects, and we're trying to get everything back on a steady disturbance regime. So the 2024 coffee pot fire, it was a natural start in the wilderness of Sequoia National Park, and it was managed, but there was a rollout due to terrain, and it threatened our sequoia groves. The unique thing about the coffee pot fire was that it happened several years after the Giant Sequoia Lands Coalition that Ben mentioned was put together. So by that point, we had a really good network of giant sequoia experts and researchers, and some people with a lot of experience burning in groves that could come help out. So as a smaller forest managing agency, we got the best of the best with sequoia experts to come help, a lot of who are on this call. And so we were able, and I have to mention the fire conditions made it so that we had about 2 weeks before any actual fire came through our groves to do some prep work. So the picture on the bottom right, you can see this is what a part of our groves looked like after we did prep work for fire. So what that meant was that the incident management team assigned us some crews, and the Sequoia experts were able to go up and kind of point out some fuels reduction work and duff raking around the base of these giant trees to clear out some of the fuel load so that we could, when fire came through, there was less risk of it burning super hot or climbing up into the canopy. So overall, the coffee pot fire was pretty largely beneficial. We got some pockets of high severity where we might not see a lot of regeneration, a lot of trees died, and unfortunately we did lose 11 of our 110 old growth giant sequoias. That being said, it was not nearly as bad as it could have been, and not nearly as bad as some of the fires that we've seen in the last 10 years affecting giant sequoias. So like I said, our resources available for the coffee pot fire was a big pro, and we got a lot of great fire. We got some really good management happening across the forest that improves our habitat and decreases the chances of a high severity fire coming through immediately in the next few years. However, we definitely have a lot of work to do now after the fire. So with our moderate and high severity fires, we have a lot of dead trees, and we might see a lot of delayed mortality in those areas where it just takes several years for the trees to actually die. So we need to go through and do some big work to clean up after the fire. And we're also monitoring our natural regeneration of some of our native forest species, specifically giant sequoia. You can go to the next slide. So we've got a lot of plans. Like I said, our biggest obstacle right now is to clear out some of the dead and dying trees. So we're gonna do hazard tree removal along the roads to provide access. And then we also have a salvage logging sale planned for this fall, as well as some green tree logging. So we did have one giant sequoia grove that did not burn in the coffee pot fire, but the density is very high, and we would like to go through and thin out some of those smaller fir and cedar trees to decrease the chances that a fire coming through would be a crown fire. We've got a lot of containment lines that were put in during the coffee pot fire. So we kind of want to take that and run with it and implement burn units throughout our forest so that we can break the forest up into smaller, more manageable chunks. Like I said, we're kind of a smaller forest managing agency, and so having the personnel as well, many agencies are having staffing issues, but I've noticed in our agency specifically, getting fire personnel to go up and do prescribed burns is really, really hard. So if I can make it a smaller, more manageable chunk, it's more likely to get done, and then we can just do a circular nature and hit each unit in a routine fashion. So our whole project area is about 1,600 acres across BLM and private land. You can go to the next slide. Yeah, so there's some standard challenges and some kind of unique challenges. I think the unique part of Case Mountain is the access. It is only accessible through 2 primitive dirt roads that gain like a mile in elevation over 11 miles, and they blow out every spring, and it's just kind of tough to get up there, even on a good day. So when there's good conditions to burn at the top of the mountain, the chances that we can get enough people up there is very low. We've gotten every vehicle known to man stuck up there. Another challenge, which is a good challenge, we have some sensitive species up there. So we've got Pacific fisher, which is that top picture, and we've got California spotted owls, which is great. And their requirements for their breeding season are hard to work around. And with an already hard to access area, it's tough to get enough time in the year to really do some effective forest management. They're worth it though. They're pretty cute. We'll keep them. Another challenge is funding. So everybody has already mentioned this, but this stuff is not expensive, or it's not cheap to do all these projects, and you need a lot of people, a lot of experienced people, and a lot of resources. Another thing that is hard that I didn't mention on this page is water access. When I'm trying to burn up there on an already hard to access spot, it is not easy to find water up there to safely contain our prescribed burns. And then just the normal government stuff of having all of our agreements and paperwork set up so that we can treat private land as well as BLM land. You can go to the next slide. All right, that's it for me. Thank you so much.
Thanks, Danielle. I'm Meg Hurdle. I'm the forest ecologist at Sequoia and Kings Canyon National Parks, currently through the Great Basin Institute. I lead the park's post-fire reforestation projects, and I specifically am going to talk about our Sequoia grove planting in wilderness and in response to recent fires. The park does have other programs that do other grove management, but I'm not going to discuss those today. Next slide, thanks. The Castle and SQF complex fire in 2020 and the KMP complex fire in 2021 resulted in large high severity patches in Sequoia groves in the parks. Additionally, due to recent fires, there's been really high mortality of mature giant sequoias, with an estimate of around 16 to 19% of population lost since around 2016. And the park also has seen low natural regeneration in these high severity areas through USGS monitoring plots after the fires. And so this combination of large high severity patches, high adult mortality, and low natural regeneration resulted in the park identifying areas that were proposed for planting. And these are on the map in blue and overlap again with these large high severity patches. Next slide. And so the park used a decision tree framework to identify which of these areas truly needed restoration planting and were unlikely to actually return to a sequoia grove and recover to that, and instead potentially type convert into a mixed conifer forest or even a shrubland. And so the map on the right shows areas that were one of our groves, Ford Camp, that we didn't plant the entire area, we just planted in the high severity area that had high adult mortality and low natural regeneration. And that's denoted by the orange crosshatch. Next slide, please. Okay, so the park planted in 2023 and 2025. We planted giant sequoia and a suite of mixed conifer species, shown here. We also planted 20% of non-local giant sequoia genetics for assisted migration. So taking seeds from hotter, drier climates and putting them into these groves that may better match hotter, drier future climate conditions. We also planted in a pattern that's scattered individuals, clumps of seedlings, and then large openings to better mimic a natural forest since we were planting in wilderness. So in 2023, we planted Redwood Mountain and Ford Camp groves for a total of around 104,000 trees, with 69,000 of those being giant sequoia. And in 2025, we planted those same groves again, as well as the additional groves of New Oriole Lake, Homer's Nose, and Dillonwood. And we were able to plant around 57,000 trees that year, with 21,000 being giant sequoia. Next slide, please. So we had a variety of challenges and lessons learned, and I want to echo everything that everyone else has already said, but I wanted to highlight just a couple here today. So first, selecting the best microsites was really important. So we prioritized planting on north sides of logs, snags, and rocks, and in depressions in order to give seedlings their best chance of survival. We also found that keeping seedlings cool was really important. In 2023, we didn't have temperature controlled storage during our planting, and the seedlings experienced pretty large fluctuations in temperatures before they were planted in the ground, and we think that might have caused some lower survival that we saw. So in 2025, we actually flew seedlings in coolers into our backcountry sites, and you can see that pictured here. This is Ford Camp in the that background slope is the actual grove, and that's also what my background is here. And you can see potentially these like white toothpicks. These are the dead sequoia trees, and so we flew those seedlings out and then hiked them to their planting units. For our more front country sites, we were able to rent a refrigerator truck to have cool storage closer to the planting site, and then used mules to actually bring the seedlings into the grove. Another point that I wanted to bring up is maybe a common challenge that a lot of land managers experience is having seed and seedling shortages. So in 2023, we didn't have all of the species that we wanted. We didn't have seed available for those species. And then in 2025, there was a tough year growing seedlings in the nursery for giant sequoias. And so we weren't able to have as many giant sequoias as we originally wanted. So this has resulted in splitting the planting across multiple years to fill just our original planting prescriptions. Another point I wanted to bring up was that it takes multiple years to collect cones, clean seed, and propagate seedlings. So it's really important to seed bank now and get those cones collected, get those seeds processed so that we can respond faster to the next fire and actually get onto the landscape, plant seedlings when the conditions are more suitable for seedling establishment in those first few years post-fire, rather than waiting 3 to 5 plus years after a fire when conditions aren't as suitable, but then the materials are actually ready for planting. And I tried to keep it brief, so I'm gonna leave it at that for my intro. Thank you.
Thanks, Meg, and thanks to all of our speakers so much. We really appreciate you guys making the time. And let me close out on my PowerPoint there. And so now we have time for a few questions. I would say I recognize that it's almost 8 o'clock on a Thursday night. So for those of you who were able to hang with us, we really appreciate it and hope you learned a lot. And we will shift now to our moderators who have been hopefully gathering questions from you all, from all of the attendees for our panel of managers.
Great, yeah. To start out with, so I know we had a couple questions that were sort of go backs to Kristen and David, but I will save those until after we've spoken with the panelists for a little bit. First one being for Marianne specifically, is that someone is wondering whether they can access the hazard tree guidelines that you referenced.
I could go ahead and share those with individuals. If you want to email me, or like if
Marianne, if you send it to me, I'll make it available to everyone. I'm gonna send a follow-up email to everybody so I can share it then.
Okay, yeah.
That also goes for anybody. If any of these panelists have any content that they want to share, you can share it with me, and then I can make it available to everyone.
Great, thank you. All right, let's see. So one question that this is kind of directed towards Meg, but other folks might have thoughts to share as well, but folks are wondering if there are any instances of management, including trying to expand smaller sequoia groves and planting outside of historic grove boundaries, either kind of in those smaller groves, or also like moving them to new places, doing kind of assisted migration. Maybe we can start with Meg and then see if other folks want to speak to that as well.
Sure. For Sequoia Kings Canyon National Park, the policy is to not plant outside of sequoia groves. So we do have to stay within those boundaries, but we've been able to do a little bit of ground truthing during the planting. And if we see seedlings that are, just outside the grove boundary, we've been able to plant like where we see naturally regenerating seedlings, if there are any, but that's been pretty sparse. So we stay we stay within the grove boundary.
That sounds like it's probably driven partially by the sort of goals of NPS. It sounds like Marianne might have
park policy. Yeah.
Yeah, kind of thought on that from a Forest Service perspective.
Yes, we, with the Forest Service, we've actually participated in what are called common garden studies, where we've actually outplanted sequoias and other conifers and other trees in specific locations outside of their normal range and from multiple seed sources to see how they grow in those areas. And that's some of the information that we've gathered over time that informs the assisted migration that folks are doing now. And so we have a fairly long history of that. We have done it with sequoias, and we've also outplanted sequoias into some of our general plantations. We did a lot of that in the 70s and 80s, so people shouldn't be surprised to find them in other locations. And of course, a lot of people like the way young sequoias look, and they plant them in their gardens, on their yards, at public sites. So you will find sequoias actually all around the world.
Does anyone else want to speak to that before I move on to another question? All right, then maybe for the whole group here, do you all kind of sometimes feel like you have to choose between planting in high severity areas and doing fuels reduction in intact forests, either in unburned or lower severity burned areas? A lot of you talked a bit about capacity, potentially being a constraint there, but do you feel like you have to make those sorts of trade-offs, and what's going through your head when you make those?
I'll chime in on this. So, I mean, first and foremost, it's getting our productive ground back into production. I was hired to be a forest manager and not a brush field manager, so I am focusing on rehabilitating the areas that got wasted and getting them back into a forested landscape. I think if anybody came out here and visited and drove through some of these areas that were burned severely, we've got trees that are 4 and 5 feet tall now. We're well on our way to establishing a new forest, but that does not discount the efforts that are taking place in the green parts of the forest, where we are doing further treatments to continue down that path of fuel reduction, knowing that, if we're looking at a 10-year fire cycle, particularly now with all the fuel that surrounds us and is even on us, we are trying to prepare for the next fire and save what we have.
Yeah, I could go next. Yeah, I mean, I think, you kind of have to do both. Unfortunately, I mean, the fortunate thing is that, the season for planting and the season for a lot of the fuels and thinning work is typically, typically different seasons, but both require a lot of input of time and energy. I think when we were first kind of looking at the post-fire landscape, our inclination was to focus in the green parts of the groves and places where we still had intact monarchs, and focus there first. And I think that, there's like the old axiom, the best time to plant a tree was 10 years ago. And I think about that in terms of improving forest health too. Like the best time to improve forest health is 10 years before the drought happens or the next fire happens. And so really focusing on those places where we still have really healthy intact forest and improving that health so that they're ready for the next fire, the next drought, the next thing that could come through.
Daniel's going to add to that as well. I can unmute you.
Thank you. Sorry, I had to join on my phone. Yeah, my only comment would be especially for a federal agency, utilizing our partnerships, it really strengthens our capacity. So if you can, it's kind of, the effort is front loaded where you're trying to establish those strong partnerships with nonprofits and resource conservation districts, and you can get a lot more work done with having those agreements. And then it just comes down to funding and all the other stuff you can't control. But to strengthen your capacity, I would rely on the partnerships.
Marianne.
Yeah, I have just a couple additional comments, in part because I'm dealing with such a large landscape like the Park Service does, over 300,000 acres. Where do you start? And we're always balancing the needs of the public, the needs of the sequoias, and across the landscape. So I'm really looking at where we can do the most effective triage treatment so that when the next fire comes, we're protecting those critical things. And in our case, a lot of it is the infrastructure and places, abutting Mountain Home, abutting communities like Sequoia Crest to Alder. Some of those have to take precedence. And then we start looking at the rest of it and lining up the things that give us the most effective treatment across that broad landscape so that the next fire does less damage and more beneficial effect.
Thank you all. I know we're getting a little close to time, but I do have a question that came in asking about kind of companion species and whether when we're planting and we're doing replanting, reforestation plantings after a fire, are we considering other species or are we just planting sequoias?
I'll chime in there too. So, during the drought years, Mountain Home, we lost almost all of our yellow pine on the forest. I mean, not all of it, but quite a bit. And the sugar pine was a close runner-up. So we actually have been focusing most of our planning post-fire to take advantage of the site preparation that the fire gave us. And we've been planting heavy to the pine species, but we are mixing in giant sequoia, but we have had really good natural regeneration post-fire in most places. So the giant sequoia that we're mixing in is probably constituting about 25 to 30% of what we're planting on the ground. So yeah, we're trying to maintain that that mixed conifer structure with giant sequoia still being a major player.
Mm-hmm.
Yeah, as Meg was saying when she was showing the planting plan for the park, we know that sequoias grow as part of the mixed conifer species at mid-elevation in the Sierras. So it doesn't make sense to plant only one species like sequoia because naturally they're growing in a mix with the other species. And so, like Jim said, we're looking at that landscape and seeing what's missing from it of the species that would naturally grow there. And that's what we're choosing to plant. So it's sequoias with other species.
And I'll just also check in on that. And for the parks planting prescriptions, we've actually used the vegetation like associations and like cover classes to have a little bit more of a prescriptive plan to change the composition of those like 6 species that we are planting, so that in areas that were previously dominated by giant sequoia, we have a higher percent of those being planted, and areas that were more ponderosa pine dominated, we have a higher percentage of those, and then less sequoia like within the grove. Yeah, so that's how the park has handled that.
And we've done very similar. So we plant when we plant, we do a mix of species as well, to recreate that mixed conifer species composition and kind of the mix of species and the density. We try to plant with kind of the topography in mind, the site class and the moisture there, and try to find the right seed mix for the right site. So it really is kind of site dependent.
Thanks, Phil. I kind of have a follow-up off of this. Oh, maybe Kristen has something she wants to say first.
Oh no, go ahead. We have a couple minutes.
Okay. So the question that came from the participant was focused a little bit, I think, more on like planting other species, but has there been any thought to the kind of like soils that we're planting in terms of like the soil mixtures that we're putting seedlings from the nursery in, or any kind of inoculation of kind of wow, I'm losing the word.
Mycorrhizal.
But thank you, mycorrhizal. Any consideration of those pieces that we know are important for trees to grow generally?
Okay, so I'll go first again. Most of what we're getting out of the nurseries anymore is already inoculated with mycorrhiza to some extent, but at least at Mountain Home, our soil was not damaged so much that the mycorrhizal component is denuded. So we are planting forest species back on forest land, hoping to recreate what we had prior to the fire, in very simple terms.
I saw a hand from David for a second, but did you change your mind?
Yeah, well, I was gonna give a half answer, which is there are research groups doing this currently with Sequoia seedlings. Meg actually nodded as well. There's not a part of the group right now. So the answer was people are doing this and looking into different treatments, different mycorrhizal soils, and other types of soils to see the effect on the seedling growth. I can't speak to the details, and no one here can as well, but it's happening.
Well, thank
I
you.
can actually speak a little bit to that.
We
also
have a minute or two left. Just keep that in mind, Meg. Yeah.
Okay, yeah. But yeah, we are underway with that soil inoculation outplanting project for giant sequoias, and we're hoping to plant them in Redwood Mountain this year. So more to come from that.
Awesome. Thanks, Meg. Yeah, and when you talk about mycorrhizae, we're talking about just beneficial fungi that live in the soil that may have been killed by the fire. And scientists are experimenting with how we might supplement those after fire. And so I want to thank our panelists so much for joining us, and David for also presenting on his recent research. You guys have been incredible, and I'm going to pass it back to Katie to just close us out. And we have a poll for you. I hope you take the time to take it. So go for it, Katie.
I couldn't have said that any better. Yeah, I've learned so much tonight. Thank you so much to all of our panelists. I just launched a 2-question poll for you all. So there's just one, scroll right down. And we really appreciate your time. It's been a pleasure to spend the evening with you all, and I will be probably mid next week, or like by Thursday next week, I will send you all an email with any of these resources that the panelists want to share with you, as well as the link to the recording for this session if you want to share it with somebody who couldn't make it this evening. And we have lots of other forest stewardship resources and information, educational stuff on these topics. So be sure to check out our website for more information on any of this work and science that is constantly coming out because of all these wonderful people. So thank you, everyone. Big round of applause for everyone once again. This is my favorite at the end of every Zoom. So take care, enjoy your evenings, and maybe one day we'll all get to see each other in real life. So, and if you have any follow-up questions, feel free to reach out to me.
See each other in real life and in the Sequoias.
Yes. Take care, everyone.